Hello everyone. Now, previous video you have seen what are the classification and how the SHM got linked with various other chapters. Now, let's start the discussion specifically about simple harmonic motion. So, let's discuss about type of motion first. Now, type of motion, if you are talking about, so the first type of motion, it is called as periodic motion. Now, as you have seen periodic motion, like there's so many example. Let's take a particle is revolving itself around some fixed coordinate, that is center. The famous example is earth revolving around the sun. Fine, let's take an earth is revolving around it. So this is a type of periodic motion. Fine. Or we can take example of UCM, uniform circular motion, is one of the type that is also classified as periodic motion. So periodic motion, there is a fix, we can say, let's particle starting from t is equal to 0, then t is equal to t by 4, covering quarter of the distance, t by 2 half of the distance, 3t by 4 is covering the 3/4 of it, and then once again returning back to the initial point. So what you can observe here, the particle is executing its motion in a certain and constant periods. So any periodic motion is supposed to be called as a special type of motion where the particle is executing its journey in a some constant time. Fine. So there's so many examples that you already know, so we'll not brief it too much. Only one thing you better to remember, the UCM, and very good example is earth revolving. That's why the days are supposed to be 24, and the month and year is also changing respectively for the sake of rotation and revolution of the earth around the sun. Now next type of motion, that is called as oscillatory motion. Oscillatory motion. Now if you're talking about oscillatory motion, so the famous example is pendulum. Fine. Here you can say pendulum oscillating about some mean position to and fro. So it look like very much resemble, because here as well we can say the time is fixed. Fine. But there is a difference between oscillatory motion and periodic motion. In oscillatory motion there is some mean position, whereas in periodic motion we can say there is no such mean position. Fine. So we can say all oscillatory motion in which no energy loss, can be periodic motion. So all oscillatory motion where the particle has not lose its energy. Once the particle lose energy losing energy, so that term is also called as damping. And recent few years there was a question asked on behalf of a damping motion in mains. So damping motion where the energy loss, this amplitude is keep decreasing its value. What is amplitude here? We can say either of the mean position, the extreme position attained by the pendulum is called as amplitude. Fine. Amplitude. So this is important note. All oscillatory motion is supposed to be called as periodic once there is no energy loss take place. Fine. But all periodic motion can be called as oscillatory motion. So this is a question. All periodic motion can be oscillatory. Kindly comment and answer this question. Yes, all oscillatory motion can be periodic under this situation. So you better to remember this situation. So I thought this much part it is very clear to everyone. We have discussed about the periodic motion. We have discussed about the oscillatory motion, periodic motion. The very connected example is uniform circular motion. Fine. Uniform circular motion, we can say uniform circular motion. And in uniform circular motion, what we can say, that particle is executing itself around some fixed point, that is also called as origin. Fine. Now on oscillatory motion there is some mean position about which particle will having to and fro motion. Fine. To and fro. So all oscillatory motion, let's sum up the things very quickly. So all oscillatory motion can be periodic. All oscillatory motion can be periodic, but all periodic motion cannot be oscillatory. Clear? So this point you better to remember as. Now let me give you good example of it. One oscillatory motion, the famous example, you can also called as spring motion. What will happen once I stretch? This is a natural position, we can say, and beyond natural position, if the spring got in this place, what will happen? There is some to and fro motion take place. So this is also a good example of oscillatory motion. Fine. This is also a good example of oscillatory motion. Now let's talk about quickly and detail oscillatory motion. So in oscillatory motion, let's detail it first. So always remember, in oscillatory motion, the general formula of force is F is equal to minus k x to the power n, where n may take the value as 1, 3, 5, we can say all odd multiple of it. So if F is equal to once F will take negative when x is positive. When x going to be positive, F take negative value, and if F is equal to positive, if x take negative value. So this is important for your understanding, because we can say for general oscillatory motion, this is the general formula of force, and we can say like any motion is supposed to be oscillatory motion once it follow this equation, F is equal to minus k x to the power n. And always remember, n can take only the odd value of it, and F is equal to minus 1x is positive and F is equal to positive 1x is negative. So if you remember, let me give you a very good example of it. Like if the ball is kept at certain height, fine, let's take these three positions. This is the position when we start offering force, and all the three conditions. To this particular situation, it is called as unstable, because once you apply the force, it will supposed to move in the same direction and never recover its initial position once again. Now what will happen here, once we have offered force, the body has a tendency to move beyond this position to and fro. So this is the condition where the force and displacement will be just opposite to each other. This direction of restoring force is just opposite to the displacement. If the body will supposed to be moving in up valley, the restoring force trying to make it once again to this original position, that is called as mean position. Fine. So this is called as most stable condition, or a stable condition will be achieved about which point, that is called as mean position. And this is the point where once we offer the force, body is supposed to be called under a neutral equilibrium. Here we can say stable equilibrium, unstable equilibrium we can say, and this is stable and this is unstable, and this is a neutral equilibrium. So once the force and displacement just opposite to each other, this is the hint for you that this motion is supposed to be also indicating the stable condition or stable equilibrium. Fine. So always remember this condition, because from here and onward we are introducing towards the simple harmonic motion. Now let's quickly take so up to now I thought if this table is clear to everyone. Now what I supposed to do, only introduce a condition for F is equal to minus kx to the power n, n is equal to 1. Always remember, n is equal to 1. This oscillatory motion equation will become simple harmonic motion. So here we can say F is equal to minus kx. This is the primary equation of force for SHM. So we have recovered this expression. This is the equation, force equation for SHM. Now every discussion we will start taking place with respect to this force equation, and we have already proven once force and displacement will be negative relation, so it will just acting to reach the stable equilibrium. It will be having motion about mean position to and fro manner. Fine. So we can say simple harmonic motion is a special case. This is special case of oscillatory motion. This is a special case of oscillatory motion. So this much part I thought it is clear to everyone. Now next class we will surely proceed the discussion ahead from this point. So we have already cleared the type of motion: periodic motion, oscillatory motion, and we have seen the oscillatory motion has this various formats, like force when the force will be positive, when the force will be negative, and the special case of it when x equal to 1, we will reach to the equation that is called F is equal to minus kx, and specifically it is called as simple harmonic force equation. Fine. So we'll meet on next time. Till then, take care and have a nice holiday.